So here is an equation which is non-homogeneous. And to solve such a question, I advise you to go for the complementary first, because there could be possible duplications. So you write down the complementary equation, whose solution is r squared minus 6r plus 9 equal to 0, r minus 3 equal to 0, therefore r is 3 and 3. Okay. If you have only one solution of multiplicity 2, like this, what's your solution? One is simply e to 3x, as before. What do you do then? What's the other solution? You multiply an x, right? So, again, this kind of has that feel to it, saying, I mean, this is like r minus 3 and r minus 3. So this operator that's acting on the function y is like twice as harsh against this e to 3x. So not only it's going to kill e to 3x, it also kills the one that's one stronger than e to 3x. That's how you kind of like intuitively understand this solution. Okay. Of course, to really check, you would want to plug it in and see it does satisfy the equation. You can do that, right? All right, so that's the complementary solution. Now let's go for yp, y particular. Now you originally look at this and say, in order to produce e to 3x, I better have something with e to 3x in it. And you put some arbitrary constant that you have to determine later. And then I also need to have e to 4x produced. Therefore, I should have something with e to 4x. And we have to figure out what a and b are. If you try it as it is, try to plug it in on the left side, it's going to fail. Why is that?
There's already an e to the 3x in the...
There's e to 3x in the complementary. And complementary means that if you plug in the left side, it's going to produce 0. That's what it means, right? So this is not going to produce, there's no way this can produce this 3e to 3x that you want, okay? So what do you do in that case? You multiply by an x so that it becomes stronger against the differential operator on the left side. However, this will still fail. Why? It's still in there. X times e to 3x is still in the complementary solution. So this is still not strong enough. This will still be killed if you plug in the left side. It's going to just become 0. So what do you do then?
Multiply by
Another x. Just keep making it stronger by putting more x. Now at this point you might ask, well, then how about x cubed or x to the 10th, right? Unfortunately, that's not good. That's not going to work either. You just need to have the correct strength so that it barely managed to produce this. If you put like x third, then not only it will produce something with this one, but it will also produce something with x times e to 3x, which is not what you want. And there will be another. I mean, you'll find out that in that case you'll be forced to have a as 0, and it's going to fail. Okay. Yes.
Why don't you keep that negative sign where it says like negative e to the 4x for b e to 4x?
Right. I mean, if you want, you can write it like this and plug it in. Okay. But at the end of the day, you have to make sure that you're plugging in the same value. Okay? But it doesn't matter, because I can say b is a negative value. Right? Or who knows, maybe it's a positive value. And you can't tell unless we actually plug it in. Okay? Any other questions? All right, so let's continue on. Let's try to plug this into the left side and see what a and b should be. So y prime of p is, when you differentiate this is 2a x e to the 3x plus 3 ax squared e to the 3x. That's from the product rule. This one will produce 4 times b e to the 4x. Since the a times e to the 3x is common, let's factor that out, leaving you with 2x plus 3x squared e to the 3x plus 4 b e to the 4x. Now let's differentiate this one more time. Y double prime. If you differentiate this, that's 2 plus 6x, a times e to the 3x. And if you differentiate this, 3 gets multiplied to everything. You get a times 6x plus 9x squared e to the 3x. And this, when you differentiate, that's 16 times b times e to the 4x. Now let's combine these two again. So a 2 plus 6x is 12x plus 9x squared e to the 3x plus 16b e to the 4x. Now let's plug everything into the left side and hope that it's going to produce the right side. Okay. So let's see, what do we get? We have a 2 12x plus 9x squared e to the 3x plus 16b e to the 4x for y double prime, and minus 6 times this entire thing, 8 times 2x plus 3x squared e to the 3x plus 4b e to the 4x, and then plus 9 times yp, which is this one. Let's copy that here. So it's a x squared e to the 3x plus b times e to the 4x equals, let's gather everything with a. So a e to the 3x has 2 plus 12x plus 9x squared, and then minus 6. Negative 6 times 2 is negative 12x. Negative 6 times 3 is negative 18x squared. And then plus 9x squared. That's everything with A. Now for B, we have 16 minus 24 plus 9. What's that? 16 minus 24 plus 9. 9 plus 16 is 25. 25 minus 24 is 1. So I just get b e to the 4x. Let's simplify this further. Okay. 12x and 12x, they cancel. 9 minus 18 plus 9 is?
0.
0. So these cancel together. So you're left with 2a e to the 3x plus b e to the 4x, and that has to equal to what? I want this to equal to what? This one, the right side, right? So it should equal to 3 e to the 3x minus e to the 4x, which means that a must be 2a has to equal to 3, so a must be 3 over 2, and b has to equal to negative 1. Okay. Then you go back and plug these in here. Okay. So to answer John's question, if you had set minus b, you would have gotten b as plus 1. So at the end of the day, you're going to get the same answer. Okay? Okay. And therefore, your yp is 3 over 2 x squared e to the 3x minus e to the 4x. And therefore, the final answer is, let's write it here. The final answer is the complementary plus the particular, that's the final. So C1 e to the 3x plus C2 x times e to the 3x plus 3 over 2 x squared e to the 3x plus, actually minus, e to the 4x. So that's the final answer. Yes?
Does this build up to having like, does this build up to having like, where like the y particular like has an A, a B, and a C, and you're going like more and more as you
Yeah,
go?
I mean, if you had, so it can get worse. If you had a plus sine x, what would you do? You would be putting plus c
And then
sine x plus d cosine x,
D.
because sine x will require sine and cosine. If I had plus x, then I would be putting cx plus d. Okay. So it gets worse and worse. But I have to tell you, it still is much better than trying to solve this directly. Okay. Trying to rewrite this as some form and trying to integrate twice to find a solution. If you compare that, this is still better.